Hi everyone, so today we're going to go ahead and multiply and divide rational expressions. Now remember that you can also apply the rules of multiplying and dividing fractions when you are doing the same for rational expressions. So the first thing that we want to do is we want to write the expressions in factored form. So we're going to factor everything that we can. Cancel out any common factors if we have any, and then simplify and reduce. So let's go ahead and look at each part. So what we're going to go ahead and do is going to look at the numerator of my first fraction. So I can factor that. I could use my box, I could do split the middle, and I'm going to get x plus 2 and x plus 5. In the denominator, I have a GCF of 2. So I take out that GCF and then I get x plus 5. In the second fraction, I can also do my box for that trinomial. So I have x minus 6 and x minus 2. And in the denominator, I have a difference of squares, so I have x plus 2 and x minus 2. Now, what you're going to go ahead and see is that if you can cancel any common factors, we can go ahead and do so. So when I cancel out factors, I can do the x minus 2s that are on the same fraction. I can have the x minus 5s cancel. And you also have an x plus 2 that's in blue and an x plus 2 that's in yellow. Now, even if they are in different fractions, it's okay because we are multiplying the fractions. So it's like these two fractions are one big fraction. So as long as one is in the numerator and one's in the denominator, it's okay to cancel them out. Now we're going to go ahead and simplify. Let's see if we can do anything more with our fraction. I have x minus 6, and then I have a 2 on the bottom, and that's all that I can do, and so that's going to be my final answer. Now here in the second problem, you can see that in the second fraction, there's no denominator, but you can always remember that that is always over 1. So we can put that over 1 just to kind of help us to remember that the 2x plus 6 is really over 1. Now what I'm going to go ahead and do is I'm going to do the same as I did in the previous problem. I'm going to factor each part. So in my numerator of that first fraction, I would get x plus 1 and then x minus 3. So that is how I would factor, again, using your box or using split the middle. In the denominator, you have a difference of perfect squares, so it's x plus 3 and x minus 3. And in the numerator of the second fraction, I have a GCF of 2, and then I have it over 1. Now, as we factor, we're going to go ahead and see, okay, can I cancel out any common factors? Now, I can take the x minus 3s and cancel them out. And then I also have x plus 3. Again, remember, when you're multiplying, it's like these two fractions can be written as one big fraction. So as long as the x plus 3s, one's on the top and one's on the bottom, it's okay. You can still cancel them out. Now, let's see what I have left. I have the 2. I have the x plus 1, keep that in together as an expression with the parentheses, and then I have it over 1. Now again, remember, you don't have to write it over 1. You could just leave it as 2 parentheses x plus 1. Now in this question, we're going to divide rational expressions. Now remember, just like when you are dividing fractions, we can use that same method. We're going to keep, change, flip. And what that means is we're going to keep the first fraction, we're going to change the division to a multiplication, and I'm going to flip the second fraction that I have. So again, notice that the first fraction stays exactly how it is. I changed from division to multiplication, and then I flipped that second fraction. So the 4n minus 12 is now in the denominator, and then the n plus 1 is now in the numerator. So keep, change, flip. Now this is a multiplication question, which is just like the last two questions. So I can go ahead and factor. So now I have that numerator. So the numerator has a GCF of 2, and then with the n squared minus 5n plus 6. You can see that trinomial, and I can see, hey, I can actually factor that some more. So that will turn into n minus 2 and then n minus 3. In the denominator, again, I can go ahead and factor using my box of n plus 1 and then n minus 2. In my numerator, that n plus 1 actually can't factor more, so I'm going to leave it as it is. And in the denominator, I do have that GCF of 4, so I'm going to take out that 4, and then I have n minus 3. Now again, let's see what can we cancel. I could take and cancel out that n minus 2's. I can take the n minus 3, right? Even though, again, they are in different fractions, as long as they're in the numerator and the denominator, it's multiplication of two fractions is one big fraction, which is also why I can also cancel out the n plus 1's. So you're going to have a 2 in the numerator and a 4 in the denominator, so 2 over 4, which can be simplified to 1 over 2. Okay, one more question. So now in this question, still division of two rational expressions. Now remember that 2x plus 1, we can always think about it. There's no denominator, but it's always over 1. Now because it's division, I'm going to keep change flip. So keep the first fraction, change to multiplication, and I'm going to flip. So that 1 is now in the numerator, and that 2x plus 1 is in the denominator. So again, let's go ahead and factor. So what you're going to notice in that numerator is your a value is not 1. So what we can do is we can still factor, but you might have to do that product sum diamond to help you to figure out what would go inside my box and help you to factor. So when you factor that, I'm going to 2x plus 1 and then x plus 3. The denominator is going to stay as x plus 3, right? Nothing else you can do with that one. The 1 is going to stay the same as well as the 2x plus 1. Now let's see what we can cancel. I can cancel out the 2x plus 1's, and I can also cancel out the x plus 3's. Now you're going to notice I just have 1 in the numerator, 1 in the denominator, kind of, right, as your placeholder. So you're just going to have 1 over 1, which simplifies to 1. All right, so here are some things for you to remember. Remember, when you are dividing fractions, you're going to change to multiplying and then flip the second fraction. So that's the keep, change, flip. And then when you are canceling factors, remember as 1 as your placeholder. As in the last question, that 1 is in the denominator, even though it's not originally written there. It's like your imaginary coefficient. So 1 is always your placeholder when you're canceling fractions. And I hope you found this video helpful. Thanks for watching and have a great day.